video is Bouyancy under hydraulics. This problem is from the CE board exam May 2016. Okay, so let's proceed. A solid object having a specific gravity of 3.5 is placed in a container containing a liquid having a specific gravity of 13.6. The volume of the object is 0.02 cubic meter. So, determine the weight of the object in kilonewton. What percentage of the total volume of the object is exposed above the liquid surface? What additional force in kilonewton is required to completely submerge the object? So, let's draw the container and this with liquid, containing liquid and an object. Okay, so letter A, let's determine the weight of this object. So how can we determine the weight of this object? Using only two given for this object, that the specific gravity of 3.5 and the volume of 0.02 cubic meter. Okay, so to compute the weight, we will be needing the unit weight of this one, multiply it by the volume. So how can we solve the unit weight using the specific gravity? Okay, so let's define first the specific gravity. Specific gravity is the ratio of the unit weight of the object divided by the unit weight of the water. Okay, so based from this definition of specific gravity, if the specific gravity of an object is greater than 1, the object is the unit weight of the object is heavier than the water. Okay, in the other hand, if the specific gravity of an object is less than 1, the unit weight of the object is lighter than the water. Okay, so let's compute the unit weight of this object. From this formula, unit weight of an object is equal to specific gravity of the object multiplied by the unit weight of the water. So in the other hand, specific gravity is a multiplier compared to the water, since we have a constant weight, unit weight of the water. Okay, so let's compute. So we can compute now the unit weight of the object and multiply it to the volume. Okay, so weight is equal to the unit weight multiply it by the volume. So what is unit weight? Again, from the specific gravity, the definition of specific gravity, unit weight is equal to the unit weight of water multiplied by the specific gravity of the object. Okay, so weight is equal to the unit weight of water multiplied by the specific gravity of the object, multiply it by the volume, this one. So from direct substitution, weight is equal to 9.81. This is the constant unit weight of water, 9.81 kilonewton per cubic meter, and then the specific gravity of the object is 3.5, and then the volume of this object is 0.02 cubic meter. So okay, we can compute the weight, which is equal to 0.6867 kilonewton. Okay, so let's proceed to letter D. What percentage of total volume of the object is exposed above the liquid surface? So the required is the volume of exposed over the volume of total, since he is asking the volume exposed over the volume total. Okay, so from this question, we have the volume of the object, which is 0.02 cubic meter, but we don't have the volume of the exposed, this one. So how can we solve the volume of exposed? That's the question. So let's try to divide the object into two. Okay, so this one, the volume of the exposed is this one, and then the volume of the submerged. Okay, and then the volume total is the total volumes. So from this, we can solve the volume submerged using buoyant force. Dito na papasok si buoyant force. Okay, so let's discuss the buoyant force. Okay, from Archimedes' principle, any body immersed in fluid is subject to an upward force called buoyant force, and it is equal to the weight of the fluid displaced. Okay, so this buoyant force is equal to the weight of this fluid displaced. So we can get the volume of the submerged using the buoyant force, since we just need the since buoyant force, this is equal to the weight of this fluid displaced. Okay, then the volume of the fluid is equal to the volume of the submerged. Okay, so buoyant force is equal to the weight of the fluid displaced. So unit weight of water, multiply it by specific gravity of water, since from the definition is equal to the weight of the fluid displaced. So this fluid, okay, multiply it by the volume. Okay, so from this formula, we can solve the volume. But okay, let's try to form another equation. From summation force vertical, buoyant force is equal to weight. Okay, and weight, okay, to let's equate this equation. Both buoyant force and then the buoyant force, this one is equal to buoyant force, so the weight, so the unit weight of water multiplied by the specific gravity of the liquid times the volume of the submerged is equal to weight, and we already have the weight of the object, this one. So substitution, 9.81 the unit weight of water, and then the specific gravity of the liquid is 13.6, this one. Multiply the volume submerged is equal to 0.6867 kilonewton, this one. So we only have one unknown, the volume of the submerged. Okay, so we can solve the volume of the submerged, which is equal to 0.005147 cubic meter. So since we already have the volume of the submerged and we have the volume of the total, we can now solve the volume of the exposed, which is required to compute the percentage of the exposed. Okay, so to get the volume of exposed is equal to volume of total less volume of submerged. Okay, and then substitution, volume of total is 0.02 cubic meter, this one, and then the volume of submerged is this one, 0.005147. Okay, and then volume of exposed is 0.014853 cubic meter, and then we can now solve the percentage. Okay, so percentage of exposed divide by the percentage of total is equal to 74.25%. So this volume is equal to 74.25% of the total volume. So, let's proceed to the next question, the letter C. What additional vertical force in kilonewton is required to completely submerge the object? So, is asking for the vertical force. If we will apply a force here, okay, the object will become submerged. Now the object is already submerged in water. So, what is the required force? Okay, so the force, this force is equal to the buoyant force of the initially exposed object. Okay, since this is only an additional force to submerge the object, we will just compute the buoyant force of the initially exposed object. So we have the volume of the exposed as already computed, and then let's multiply it by the unit weight of this water. So, okay, the additional force is equal to the buoyant force of the initially exposed. Initially, because this is initial lang siya kanina. And then, nung nag-apply ng force, it is already submerged. Na-submerge na siya. So, okay, force is equal to the buoyant force of the exposed. Okay, so force is equal to, what is the buoyant force of the initially exposed, which is unit weight of water, multiply it by specific gravity of the fluid, multiply it by the volume of initially exposed. So, substitution. Okay, unit weight of water is 9.81 kilonewton per cubic meter. Specific gravity of fluid is 13.6. And then volume of exposed is 0.014853 cubic meters. So, force needed to submerge the object is 1.98 kilonewton. Okay, so let's recap. Determine the weight of the object in kilonewton. The answer is 0.6867 kilonewton. Letter B. What percentage of the total volume of the object is exposed above the liquid surface? So, volume of exposed divided by volume of total is equal to 74.25%. Okay? Letter C. The additional vertical force in kilonewton is required to completely submerge the object is 1.98 kilonewton. Thank you.